Hello friends, welcome to our channel Knowledge Amplifier. So today in this particular video, I am going to discuss about ELT implementation in Talend. Okay, one of the data pipeline design technique is ELT. So before going ahead with Talend implementation of ELT, let us try to understand what is ELT. Okay, so before going ahead with ELT, let us try to have a quick recap of ETL, which is one of the most popular pipeline design technique in big data domain, right? So what is this ETL? Extract, transform, and then load. We extract the data from various sources, that may be comma separated file or tab separated file, or maybe some database, or maybe some link from which we are extracting data using REST API. Okay, right? And then we apply certain transformation, which mostly depends on business use case. That may be aggregation or sorting, or that may be filtering, whatever. And then we load in the target. That target may be some S3 location, or that may be some cloud database, Redshift or Snowflake, or that may be some normal databases like MySQL, SQL Server or Oracle, whatever, right? There are various softwares and technologies available to do this ETL technique. Very popular, some of them like Talend, Informatica, Spark is there, Ab Initio is there, Oracle Warehouse Builder is there, Pentaho, a very popular free that is open source ETL software is there, and then Oracle Data Integrator is there, right? So all these are very popular tools to do ETL in the big data pipeline design, right? Now, what is ELT then? ELT is extract, load, transform. Okay, so this first picture is indicating ETL. That is what we generally do. First we extract the data from various sources, then we apply certain necessary transformation, that may be aggregation, that may be sorting, or that may be string handling, that may be data clearing, okay, null value removal, or many other steps are there based on business use case. Okay, many joins we do, that is whatever important data or useful data with respect to business intelligence point of view, that only we try to achieve in this transformation phase, and then we load, right? But this is what is ELT. First we extract the data and then simply we load, okay? And where we load, there if required, we apply different transformations, okay? So what happens, if you try to understand the major differences, you can easily understand that once we get the data in this particular target, after loading, what happens, the business analyst or business intelligence team takes the data and they may make some data visualization, maybe using Power BI, or that may be using Tableau, or maybe just for analyze purpose they can use some SQL query on this data, whatever. They mostly do not apply some particular transformation on this data. But what happens in ELT, once the data is loaded, whatever transformation is required, that is applied after loading. Okay, so basically loading and transformation are happening at the target only. So this is the major difference between ETL and ELT. Okay, so what is the advantage of ELT if you try to understand? Let's see, once we extract the data in ETL pipeline, first transformation is done and then loading is done, due to which some delay happens in the loading phase. Okay, but here in this ELT technique, if suppose the business require the data very quickly, we can use ELT because we are extracting data and then directly loading. Okay, so what happens, that it is becoming faster because we are not doing the transformation before loading, right? So this particular ELT, in the ELT way, if you design your pipeline, then obviously as quick loading happens, then this can be useful for certain businesses. Okay, this is one of the major advantage of ELT, that we can get the data in the destination side very quickly. Okay, right? Now some more advantage if you try to consider, that mostly there is low maintenance in the ELT. Okay, right? Why? Because the reason is very simple. This ELT, okay, that is L and T, that is loading and transformation, what we do in this particular pipeline, mostly on cloud architecture, and version controlling and all these stuffs are handled by cloud architecture itself, whatever cloud architecture you are using. there is not that much manual work is there in those version change or maintenance purpose. But if you consider ETL pipeline, as we are doing transformation, what is happening basically that here cloud architecture is not responsible for version control and all those. So this manual involvement is more in this ETL part. Okay, more maintenance is there in this ETL side, right? Then some other difference if you consider, in ETL pipeline design, the source of extraction of data can be some flat files, or that may be some comma separated file or tab separated file also possible. Okay, but in ELT the source always is a database. Okay, we are extracting the data from database and then we are basically here doing transformation and loading. Okay, this is how in Talend it works. So with respect to Talend, if you want to design this ELT pipeline, always the source should be also a database. Okay, right? So this is another difference. And then if you try to understand with respect to computation aspect, then ELT is better than ETL if you are working in big data domain. Why? See, suppose you have extracted huge volume of data from source. Okay, that may be any source. Now when you are doing transformation, that time mostly on our RAM we are doing the transformation, right? And then we are loading the data. So this transformation, high level of operations, okay, data transformation operation based on business use case is happening on our RAM. So that is a very expensive computation. But if you consider ELT pipeline, the transformation we are doing at the target, and as target mostly is cloud architecture, that may be Redshift or Snowflake like that. So in cloud architecture, doing complex data transformation is much more efficient than doing in our RAM, right? So in ELT process, it is better if my data volume is very high, then it is better to follow ELT, because the data complex transformation what we are doing in this ELT pipeline, we are not doing on our RAM, rather we are using the cloud architecture to achieve this, right? So this is another very important advantage of ELT over ETL. Now the question might appear, so in near future completely the ETL will be replaced by ELT? No, it is not like that. Because in ELT, we can use the power of Java, Python, okay, or Scala in Spark environment, all those. But in ELT, when you are considering, see, the source is database and target is also database in case of Talend. Now, what happens? We have to rely only on SQL for this transformation, okay? What happens in ELT? Suppose there is a particular table present in Snowflake, another table present in Snowflake. We want to apply certain business logic on this, and then we want to create a new table. So this thing, what will happen? Suppose you are using Snowflake architecture, then only way to go with is SQL, right? So this is one of the major restriction in ELT pipeline, that you have only SQL for data transformation, whereas in ETL you can use the power of the programming language like Java, Python and so on, right? Scala is there. R language also is supported in case of Spark, right? So these are some advantage and disadvantage of ELT and ETL. Now let us try to understand how we can implement the same using Talend, okay? So first let me go to web interface and let me select, okay? So here role is sysadmin, warehouse is compute, WH is there. Database is ABC database I am using, schema is public, okay, right? So let's see, select star from, let us take two tables, okay? So select star from, so if you check in our ABC database in the public schema, these are the tables present, okay? So let me take this one, select star from nation, okay? Let's run this. So if I just make this a little bit upper, see, you can see that what is the data present in this particular nation table, right? So nation key, nation name, nation region key and in comment, okay? All these things are present. There is one more table is region. Let us check that. Select star from region. Okay, so if I just run this, you can see that this is the region table. R region key, R name, and R comment is there. Okay, so what is happening? This nation and region are deleted with the region key. See here, region key column is there, and if you check the nation table here, N region key is there. Now suppose we want to do join and then apply certain filtering. Okay, so let me take all the let me write one query. Okay, so maybe nation key we can take. Okay, select nation key, comma nation name. Okay, and nation region key also let me take. Nation comment also let me take, comma let me take the tables from our region table also. Region name will take. Okay, region comment also will take, and okay, that's it. So as we are already taking region key here from the nation table, no need to take from region key of region table, right? Now what we can do, select all these columns. Okay, from nation, let us do inner join region on nation dot, what is the column of nation table, that is in region key, right? On nation dot region key equal to region dot R region key. Okay, so like this we are doing if joining. Okay, right? So let us run this and check whether the code we have written correctly or not. Yeah, so you can see that you can understand from the basic school level geography concept also that see Algeria is present in Africa, Argentina is present in America, like this. That is the countries we are trying to basically join with the region. Okay, right? Now suppose we want to apply one filter condition where, let me go to next line, R underscore name equal to Africa. So let me take only those data points which are belonging to country Africa. Okay, now you see these are the only 5 records belonging to region Africa. Okay, so we have joined 2 tables and we have taken only data belonging to Africa, right? Now this is what we want to do using Talend, right? So what is the basically fundamental aim? First I will create a ETL pipeline and show you the operation, and then I will create an ELT pipeline and show you the same operation with the difference. Okay, so let us go to Talend and start creating this. Okay, so go to standard and then create a standard job. I am giving some name, click on finish. Okay, it might take some time. Now let us bring the component. So T pre-job is there, and then we will create the Snowflake connection. So T Snowflake connection. Okay, here we are taking the connection and we will trigger and write on component. Okay, that's it. Okay, now what we'll do, we need to bring the data in the ETL pipeline. We need to bring the data from Snowflake to Talend. So this is kind of, in Talend we are taking input. So T Snowflake input component will take. So this will be used for one table. For the next table we will use, that is 2 tables are there, right? One is region and another one is nation. So 2 input components is required. Okay, sorry, here already it is coming. Let me drag and drop. Okay, then what we will do, we can apply tmap component. Okay, normal tmap component for doing that joining and all, and then we will send the data after applying join and filtering based on Africa region, and we will create a new table in Snowflake. Okay, So T Snowflake. So from Snowflake we are sending the data, from Talend we are sending the data to Snowflake. So this is kind of output, right? So T Snowflake out. That's it. So these are our more or less component. So main connection will be making because we want to pass the data, and here also main connection will be creating. Okay. So once the main connection is created, what we'll do, here we will create a new output, and here we can give any name, data flow maybe. Okay, right? And now we need to, once the transmission is done, what we have to do, we have to, once the table will be created, we have to commit this, right? So T Snowflake commit, and then here we can do this once this particular sub job gets success. So we can trigger based on sub job. Okay, what is this one? Let me keep here, and then once the particular process is done, we need to close the connection whatever we opened here, right? So T post job we will create, and then here what we'll do, T Snowflake close. Okay, right? Up to this also I hope it is clear. On component. Okay. And one more thing you can do, if this particular pipeline fails due to some reason, you can do rollback also. So T Snowflake rollback is also there, like the normal what we do in SQL, right? So this will be on subjob fail or on subjob error. Okay, so if the subjob gives error, then TDB rollback execute this one. So this is more or less our ETL pipeline, right? So now let us configure this. So double click on TDB connection, and then Snowflake. First we need to give account. Okay, all these things. So let me go to Snowflake, and then here let me take the account. Account is only this much, nothing else. Okay, only this particular unique key. Alt F, and here I'll go to Talend. Then here in account I will put that value. Right. Once I put the value, what will happen? What is our region? Our region is, if you check in Snowflake, our region is US East 1 AWS. Okay, so I will put that accordingly in Talend. So here it will be AWS US East. Okay, what is user ID? User ID, I will be giving user ID for my account, you give for your account. Okay, password, securely give password. So once you give the password, we need to specify warehouse, schema, and database. Let us check what is our warehouse. Our warehouse is compute WH. Okay, let us give that. Right. What is the schema name? Let us go and check. Schema name is, we know, right, that public is the schema name. Okay. And what is the database name? Database name is ABC, what we are using, right? So this makes our configuration. Now we need to create our, we need to take those two tables. Okay. So here what we will do, we will click on input component, and here connection component, use this component. Where what we will use? We will use TDB connection one. Whatever connection we have created here, we are going to use that. Now click on table. So we need to take our table, right? So we'll click on this, and then it will go to that particular Snowflake, and whatever we have created here, the connection, based on that it will go to that there, and it might throw some error if it is no suitable driver found for database Snowflake, ES1 Snowflake. Okay, I think I have given wrong name. Let me go to TDB connection. Here I forgot to give compute WH, spelling mistake is there. Anyway, let's go back, and then here click on this. Okay, see what happened. Whatever connection we specified here, based on that it is listing me all the tables present in that particular database. We require the nation table. It is listing all the tables present in the database, and we require the nation table. From that we can click on OK. As soon as I click on nation, what will happen? Automatically it will extract this schema. We no need to specify this schema separately here. Okay, I'll show you that. Let it extract this schema. If I click on edit schema, you can see that all this schema, that is column names, their data types, all this is extracted by Talend automatically. See what is the type also. Click on OK. We no need to handle anything here. Now let's do the same way for second input component. Second input component is region. So I will choose TDB component, TDB connection 1, and then again click on this one, and then again it will go to Snowflake, that particular configuration will extract all the tables, will show me those, and from there I can choose that region table, right? So I can click on this region table, click on OK, and again what it will do, it will extract this schema by itself. We no need to do anything for the time being here. Okay, right? Let it do its work. So see, if I click on edit schema, the schema, or that is column names, data type for the region column, it is extracting. Click on it, right? So this configuration done. Now what we need to do, we need to go to tmap and we need to do whatever transformation we want to do, right? So here I want to select all the columns from the first table, that is nation table. I will simply drag and drop here, and I want only the name and the comment from the region table. I don't want region key anymore, because region key present in region table and region key present in nation table are same, indicating same thing only, right? That is our join column. Okay, so we need to take the join column only once at the output side, right? Now how we are going to do join? Based on region key, right? So select the region key from nation table and drag and drop here on the region key of region table. Okay, it is indicating the connection. What kind of join we want to do? Here if you click on this one, see here what it is, by default it is left outer join, but what we want inner join. So click on this and then select inner join and click on OK. Inner join is set, and something more we want? Yes, we want to apply where condition on row. So click on those, and then here we can specify the where condition, right? So what is the condition we are applying here? If you check, so basically we are applying the condition on the name of region, and we want to select only Africa, right? So I will go to Talend and see, we are applying on the region column, which is coming from this region table, right? So here our name on this one, right? So this is the column on which we are applying filtering. So row 2 dot r underscore name equal to Africa. Like this we can do comparison? No, because Talend is based on Java, so we need to use Java comparison, right? So dot compare to equal to 0. So what we are doing? We are applying compare to function present in Java for string comparison. We are just taking those data which are having the region name as Africa. That's it, nothing else. Okay, click on apply and OK. Would you like to propagate changes? Yes, I want to propagate changes. So this completes our tmap design. Now click on TDB output. Click on connection component, TDB connection 1. Okay, what is the table name? So we want to create a new table in Snowflake, okay, whose name we can give like maybe output ETL, to indicate that that particular table is created using ETL pipeline, not ELT pipeline. Okay, so if you want to create some new table, you can click here, use custom object, and here you can give output ETL. Okay, using ETL we are creating that. Okay, click on OK, right? And what is the action you want to do? You can select from that. So create if not exist. That's it. Output action is insert. Insert, update, upsert, delete, all these are present, right? So once that is done, I think we are good, but let us configure the rollback and commit also. So here double click on rollback and select TDB connection 1, double click on commit, and here also select TDB connection 1. And connection you have to close, so click on TDB close and then click on TDB connection 1. Let's run this and let us check whether the output ETL table is created or not based on our transformation and requirement. Now see, this is what we are doing. We are doing ETL, right? That's why you might see that here records will come. It will show that records are coming. You just observe on these two connections. You can see that the records will start coming. Okay. It might take some time. See here 5 rows, 1 rows, 25 rows, like that. In the output side it is showing 5 rows. Okay. So basically this is indicating what? This is indicating Talend is extracting the data from the source database and applying the necessary transformation in RAM. Okay. That is on the environment where Talend is running, and then putting the data back in the Snowflake. Okay. That is its area of work for the transformation is the computer RAM which I am using, right? And that's why see here you can see the 25 rows are extracted, 5 rows are extracted from these two different tables, and then after filtering only 5 rows we are sending in output cell. Let us go and check in Snowflake whether the table is created for us or not. Okay, what we can do? We can do select star from here. We can just refresh the particular one to check whether our new table is created or not. See, output ETL is created, right? Okay, let me take this one. Output ETL. That's it. Select start from output ETL and let's run this. Okay. So see, whatever we wanted that we are achieving. But this is how we are getting. We are getting using ETL pipeline. Now, what is the ELT implementation? Let us look into that now. Okay. Before going ahead, let me tell you that one advantage of using ELT pipeline in this particular case, okay, that is query optimization or query execution optimization, you can say. Like in Spark, if you have studied Spark, you might know that there is a catalyst optimizer present, right? That do filter pushdown or query pushdown. Similarly, here in Snowflake also, query pushdown or filter pushdown is there. Let me discuss about that little bit. So suppose I am having a particular query like this, select country, comma, count of country as message from table 1, join table 2, where this is the join condition, and we are applying one filter condition, that is table 1.code not equal to info, and then we are applying group by operation based on country. So what will be the execution flow for this particular query if you observe? So what will happen? First, suppose there are 2 tables, okay, 2 tables will be scanned and then joining will happen, okay. Once the join happens based on this particular join column, filtering will happen based on this particular condition, that is only those records will be going to the next stage where table 1.code not equal to info, and then we will project the data and then we will do aggregation for this count of country based on country, okay. All these things. So this is a typical execution flow for this particular query, right? But if you think wisely that this can be optimized actually. What we can do, see here join is always a very expensive operation, right? You can understand that many shuffle happens. Okay, the table, both the tables has to be traversed, and then proper connection has to be made, and then proper mapping has to be made, all those things. So what we can do here actually, if we execute the particular SQL query like this kind of tree architecture, at the initial stage, we are extracting complete data from both tables and then we are joining based on complete records from both tables. But at the end of the day, we require only those records as output for which table 1.code not equal to info. So what we can do, as joining is a very expensive operation, so let us do this filter before joining, and as a result there will be less amount of record for join operation, right? So this is one kind of optimization which is called filter pushdown or query pushdown, like that, okay. So if you check, what I want to say that first do join and then do filtering, rather than that, as join is an expensive operation, so to reduce the number of records before joining, what we can do this particular filtering on table 1 column. Suppose this particular right side is table 1 Okay, so what we can do filter first and then do the join. Okay, so that here at this particular join stage, lesser amount of data will be there to join. Okay, and as a result, the amount of resource consumption will be reduced by some amount, right? So this optimization in Spark is done by Catalyst Optimizer. Snowflake also does this kind of optimization internally. Okay, that is, it will understand that, okay, here we are doing one filter condition, so let us do that filter condition first before doing the join. Snowflake internal architecture will handle this particular query optimization. Okay, we no need to bother about that. When we are doing ETL, extract, transform, load, that time this kind of optimization is not done. Okay, because we are not using the computation power of Snowflake. What we are doing, we are extracting the data and we are using the transformation power of Talend on our RAM. Okay, but what we can do when we are going to ELT, that is extract, load, transform, then as after loading, we are doing the transformation on Snowflake only. So Snowflake will do this kind of filter push down, okay, and optimize that query. And as a result, what will happen when we work in big data environment, this kind of optimization will help in saving lots of resources, both with respect to time complexity and space complexity. It can be optimized. Okay, right? So let us have a look how we can implement ELT pipeline in Talend using this Snowflake database architecture. Okay, so let us go to Talend. So what we can do, we can click on the standard, we can create a standard job, so we can give the name ELT Snow. This item is already exist. Okay, click on that, and then here our new workspace is created. What I will do, the connection I will copy directly from here, Control C, and here Control V. Okay, this particular component also, what I will do, I will do Control C, and here I will do Control V, because here no changes, just we are making connection, we are closing connection. What will change? The architecture will change here. Okay, so here you can see, you can understand the data is brought from Snowflake to Talend. That's why it is showing like this 25 rows, 5 rows are coming, right? But here when I will show you the ELT pipeline run, you cannot see such data coming in that connection. Let me show you that. So T Snowflake. Okay, what we can do, I can show you from palette only. So here I can go here and let us check where ELT component is there. T ELT, just search. Okay, so see here some ELT is there. Okay, so we will be working only with these three: TELT input, TELT map, TELT output. Okay, so TELT input 1 for nation table, TELT input 2 for our region table. Okay, TELT output for creating a new table after doing the join and that filtering, and TELT map for the for doing the join and filter condition. Okay, we can connect one link. Okay, before that, let us click on TELT input and do the necessary setup. Okay, so what we can do, default table name. Default table name is what? Here the table name is nation. Okay, schema name is public, right? What is for this one? For this one, table name is region. For this table name is public, schema name is public. Okay, mapping type not MySQL, it will be Snowflake. Make sure you are doing this Snowflake. Here also let me do that to Snowflake, right? And then here make the connection. Okay, see public dot nation table is coming, and here this will be public dot region table is coming. Okay, then here what we can do, TELT output. Here we can do action on table is create if not exist, insert default table name. What we can give the table name, what we have given in ETL, like that only we will try to keep the convention. Output ETL we have given, right? So here I will give output ELT. Okay, so here I can write output EL. Let me write in small letter, although it does not matter that much. Okay, schema name is public. Okay, right. So this is done. Mapping is Snowflake. So we can connect here. So output ELT table is done. Right. Now click on TELT map and this kind of window will open. Use an existing connection. Here see we have already created the connection, right? We are going to use that only. So TDB connection 1, right? So this connection is established. Click on this one. Okay. And then here click on plus. Here we need to take the nation table. Click on OK. Right, and one more we require the region table also, public.region. Click on OK. So these two came, but see here we cannot see the column names and all, so we need to take that. So what we can do, we can go there and then here edit schema, we can click on that. Okay, so here we need to define the schema, right? So what we can do, we can just copy from here, because here the Talend created for us, but in ELT component it has not done. So let us just paste there by doing Ctrl+C and Ctrl+V. Okay, so this is the schema for the nation, and for region, the schema we can take from ETL pipeline only. Okay, no. This is not, this is coming as nation only. Post this for region, this one. Copy this, Ctrl+C, OK. Go to region, edit schema, Ctrl+V. OK. So here now for our nation and for our region, the schema is ready. Double click on ELT map. And now here, what we have done, we have taken all the columns from nation table and we have taken only the name, region name, and here comment, region comment. What is happening? Yeah. So this is done. The architecture is created, but here we need to define what kind of join we want. So here we want inner join. So click on that, and inner join is an explicit join we are defining. So based on region key, so we will drag and drop region key on region key from nation table will map to region key of region table, and we will click on explicit join, because this is explicit join, not implicit join we are doing inner join, right? So this is explicit join. So click, check this one also. And here what you can do, you can see the query which is generated. See, generate SQL query. See, select public dot nation comment, in comment, public dot nation dot in region key, all those from public dot nation inner join, public dot region on all this. Okay, and we want to apply one where condition, so we can click on this, add a where clause, and here what we can do, we can specify the where clause based on region name, right? So region name is coming here, that is this one. Okay, we can just drag here also, or if it is not dragging, what we can copy from here, and here we can paste equal to Africa. So see, here we are doing SQL kind of code, okay, not compared to all those like Java. See here, it will be updated. So this where clause is added, click on OK. Now if I just double click on ELT map again, you can see that the query, okay, generate SQL query, see here, public.region.region name equal to Africa. Okay, so it is coming properly. Right. So this is what about our ELT map component, right? So I hope you have understood what we are doing here. Then click on Okay, this more or less completes our stuff. Just what we need to do, we need to specify that rollback and commit. So T, or that is not required in this case. If you want, you can put that, else you can ignore also. So let's what we can do now. Let's run this. So you can see here some error we are getting. It's compile error. Okay. Let me check. Public mapping is Snowflake. Edit schema. Okay. So ELT output has no schema. So what we can do, we can click on sync columns. Now let us check. Yes, schema came. Now let's run this. Yeah. So see here, exit code 0. That means the code is executed. What is the insert query is executed also. Here you can see insert into public.output ELT, all these things. Okay, and select query and then where condition. Let us go to Snowflake and check directly. So if I just make it refresh and go to public, here you can see output ELT component is also created. Okay, let's check that. So here what I can do, I can just copy this query only and here paste. Instead of ETL, I can write ELT. Okay, select star from output ELT. Let's run this. We will be getting same output as here. Select star from output ETL. Okay. Let me do one thing. Let me download both of them as CSV file and let me show you that both we are getting same. If I just open, okay, let me copy this. So this is our first result and this is our second one. See, same only, no difference. So in this way, we are getting the same output using ELT and ETL. But what is the advantage of ELT if you check? See here, earlier if you check ETL Snowflake, so sorry, actually this will be ETL Snow. So in this particular pipeline, you can see the rows are coming from input component to tmap. That's why this kind of this much rows coming in this much second, this amount of rows per second, all this information it is showing in Talend. But here when you are checking ELT component, see it is not showing because Talend is not at all bringing the data in this environment. What is happening? It is only executing this particular query. Whatever we have generated here, see generate SQL query. This particular query, it is executing in the Snowflake only. As a result, what is the advantage? We are using the compute power of Snowflake, which is a cloud-based architecture, okay, which can handle big data very easily, and this much transformation can be done very quickly using this ELT component. But if you are using ETL, that time the problem is that it will use our RAM as a execution platform, and as a result, it might slow down in our big data scenarios. Okay, so this is what about ELT. I hope you have got the idea how you can do ELT pipeline design using Talend. This is all for this video. Thank you.